In the last lecture, we started with the introduction to the blockchain. Before moving on to the blockchain, first of all, we have discussed the general business environment in which the business environment involves many entities such as customers, manufacturers, banks, financial institutions, pyramid partners, stakeholders, and many other people will be involved in the business. And whenever the business is going on, it will not go in isolation. Always it will be done with the help of many entities. And also some business happens through markets and sometimes they will be private or sometimes they may be public also. That means the business happens through private networks and also maybe some public markets. Especially in these businesses, the exchanging of the assets will happen. The asset may be goods or services. And these assets may be tangible, sometimes intangible also. Tangible means that you can see and visualize, like we can like house, car, etc. are the tangible assets. Intangible means that you cannot see, only you can imagine, like mortgage, bonds, patents, this kind of things. So the movement of assets across various entities in a business network are recorded into a ledger. So obviously, it is just like how a security person at the gate level will record who is coming inside and who is going out, and what is the time in, what is time out. It is a kind of a transaction. Okay, that like that. What are the assets which are going across various entities in a business network are recorded into a register, which is called as ledger. A business may have multiple ledgers. An asset transfer onto or off the ledger is said to be transaction. So obviously, a business may keep their own ledgers, obviously, and whatever the assets that will go here and there are recorded into the ledger, which is called as transaction. And if this particular transaction happens via condition, then it is said to be the contract. So these are the various terminologies that are going to be used in the business environment and meaning of each terminology. Now, why we require this terminology? Because other than the cryptocurrency, the blockchain will be majorly used in the business environments. So hence, whenever we represent the business environment, business applications with the blockchain, we need to frequently come across with these terminologies. So that is the reason we discussed this. And also we have seen the conventional ledger model, how dangerous it is, because every person in the business network, like the participant A, participant B, bank auditor, regulator, and all these people will be having their own ledgers. Okay, whatever the entry made in this ledger is not known to the participant B, and whatever the entry made in this ledger may not be known to the bank person and auditor, regulators. So whenever the auditing is happened, the auditor has to go to each and every person and has to verify this ledger. So it is somewhat costly effort and also time consuming and somewhat risky also. So that is the reason if the separate ledger was kept at the each level, every individual levels, then obviously it will be somewhat inefficient and sometimes expensive also, and sometimes vulnerable also, because anyone can change the can change the entry in the ledger according to their wish, or they may keep the replicated copies of the ledgers, so that whenever any inspection comes or auditing comes, they may not show the original ledger. They may show some balanced ledgers where all the things were balanced. So in such a way, it is vulnerable. Now, what this particular blockchain will do? So in this blockchain, actually, we have come across how to secure or how to achieve the confidentiality, integrity, and authentication, and also non-repudiation whenever the transaction is entered into the ledger. That is with the help of cryptography. These concepts we have seen in the last lecture, and also we have seen some games like the average sum secure game, where the customer where a company wants to know the average age of their customers using its product XYZ. many customers are not willing to provide their age. So the company, what they did is they said that, okay, you provide the age without knowing to other person. Okay, we will calculate the average age. So hence this game is about how to collect and calculate the average age and secure some of the age. Next one is secure rating of a product. A company launched a product and first asked their employees to use the product and provide the rating to it. Now the game is to collect and average the rating of the product from the employees without revealing their identity. You look at the company in the game one is providing a ledger or a register and asked to enter their age. Okay, the same register is going to other person, and that person also should also provide the age. Like that, the same ledger is going to other person, participant 3 or employee 3, and that employee should also register their age. Like that, the same ledger is going to all employees. So whenever other employee receives, any employee receives this particular register, obviously he has a chance to go through the ages of the previous employees. So now here the question is, how, without knowing the age to other employees, how you are supposed to manage it? Okay, you may do encryption, okay, and you can do some manipulations in it so that age may not be known to the others. Like that, secure rating of a product. Here, a company will provide you a register in which the product and will ask the employee to provide the rating. And the rating should not be the identity should not be revealed. The employee's identity should not be revealed. Who have provided the rating. So again, it is like a transaction which is entered into the ledger, and that ledger will be, or ledger or register will be sent to other employee, and that employee also should record his own ratings for the each product they consume. Like that, it has to go further. No other employee in this transit of the register should be in a position to uh, view the rating of the products. Okay. Next one is secure donation, a voluntary organization collecting donations for a public cause. Now the game is that some donors are not interested to reveal their identity and do not willing to reveal the amount they donate. So whatever the amount they are donating and also identity. In the first case, in the game one, only age, okay, only the number they are going to hide. Where in case of rating, in the second game, ratings can be viewed, but who has provided the rating should be hidden. But in case of game 3, both the donation, the one who is providing the donation and the amount they are providing, both should be hidden. Okay. So this should be happened in a public domain, where the register will be shared among various employees and various donors. In that case, the details should be hidden. That means in a public domain, the details should be hidden. So for that, the best and suitable technology that we can use is cryptography, because cryptography will ensure us the confidentiality, integrity, authentication, and non-repudiation properties. So we are going to use that cryptography and we can deal with that. So far, in this, nothing, money was not involved, only the business or some rating and this kind of things were involved. Now we'll see some interesting one where the money is involved. First is, there exists two people, Ramu and Gopal. What the Ramu is doing is, Ramu is providing ₹100 to Gopal. Ramu and Gopal both are the business people, okay, and they have a business network in which they will do some financial transactions or financial operations, maybe like chits or what, this kind of things. So Ramu has given ₹1,000 to Gopal. So whenever the 1,000 has been given in his ledger, he will write that, Ramu's ledger, he will write that to Gopal ₹1,000. Okay. Now, whenever the Gopal receives 1,000, he should also register in his own ledger that from Ramu, okay, he received rupees 1000. This is the genuine way of writing the ledgers. But what happened? Okay, Ramu got a brilliant idea. So he has written in his register that to Gopal 1500. Okay. And also Gopal is also somewhat brilliant. Okay, what he has written is from Ramu I have received only 500 rupees. But actually, how much has been given by Ramu? It is 1000 rupees. How much actually Ramu and Gopal has to register in their ledgers as it was shown in the green color, to Gopal rupees 1000 by Ramu, and from Ramu 1000 rupees by Gopal. This is the proper way of writing. But because of some mischievous or some corruption kind of thing, okay, Gopal might have Ramu might have written that to Gopal 1500. That means he has written 500 rupees additional to the actually what he was given. And Gopal has written 500, almost 500 rupees, 500 rupees less than the amount actually he received. Okay, but up to here it is only 500 only. But actually, you look at here, he has sent 500 rupees additionally. But while coming to here, if you believe this, that is 1500 was sent by Ramu, but Gopal has received only 500 rupees. That means where is the 1000 rupees gone? Actual transaction is only 1000 rupees. But if you compare these two ledgers, then obviously there is a too much discrepancy. That is the reason it is better whenever money and some other transactions are involved. We all know that our elders used to do. Okay, we used to place some third person or fourth person as a witness. So we feel that okay, this person is the third or fourth person who is acceptable to the both parties. Will place will trust them and will make them as the witness. So we are doing this contract. We are making this contract. So you must be a witness, and you please put the witness signature like that. So now Ramu has given Gopal rupees 1000. This is the transaction was generated. Okay, assume that these people are in the digital environment and in a network. This Ramu to Gopal rupees 1000 is a transaction generated. Now this generated transaction will be sent to Ishwar, Paras and Radha for verification. Okay, so this transaction will be sent to Ishwar, Paras and Radha for verification that Ramu has sent Gopal rupees 1000. Now that means just now we discussed that this Ishwar, Paras and Radha are the witness. They have to approve this. Okay, they have to approve this transaction so that it will be that this particular transaction will be committed. So they are the witness for this particular transaction. So whenever the witness is there, first of all, Ishwar, Paras and Radha should know what is the already available amount with the Ramu. Whether Ramu is already having this particular 1000 rupees or not, to be first verified, and whether this transaction has to be as started or initiated from Ramu itself or not should be verified, and whether the Gopal identity is correct or not also should be verified, and the amount whether actually Ramu is having the balance of 1000 rupees or not is also verified. It is just like if you go to ATM and your balance account is balance amount in your account is maybe 5000 rupees. If you are trying to draw 1000 rupees, the ATM will not accept it, because how much is the balance you are having, from that only you can do any transaction. Like that, if he is sending 1000 rupees to Gopal, means whether the Gopal is Ramu is actually having 1000 rupees or not to be verified. Clear? So when this should be verified, in order to verify this, first of all, Ishwar, Paras, Radha these three witnesses should already have the details of the Ramu, okay, how much amount is already having, and the identity of Ramu and the identity of Gopal. Then only they can witness. If they perform the, if they have the information, they can easily verify whether Ramu's identity is correct or not, and here Gopal's identity is also correct or not, and the amount what he is transferring, whether he is actually holding this amount or not. So here I have written in general English like Ramu, Gopal, but actually whenever you do any transaction, online transaction or internet transactions, obviously the account number will be there. From this account number to this account number, this much amount was transferred. Like that, the transaction will be generated, and along with this, some metadata will also be there. What is the date of transaction, time of transaction, and transaction number? Like that, some metadata will also be attached to this. Now, for this, you need verification of the account, validation of the account, and also the Ishwar, Paras, and Radha, who are the witnesses, should come to an agreement that okay, I have performed at my level. Ramu has sent Gopal to 1000 is a genuine one. Paras has to decide to come to a conclusion that okay, Ramu to Gopal 1000 rupees is a genuine transaction. At the same time, Radha should also feel like that. Whenever these three witnesses have felt that this particular transaction is a correct transaction, then it is said to be that Ishwar, Radha, and Paras, who are the witnesses, have reached to a consensus. On the transaction that was happened between the Ramu and Gopal, and if the consensus is accepted, and this particular transaction will be committed. I hope by this time you come to know this is the general way of doing, but how it can be done in real world. So this particular transaction has to be verified. In order to verify this transaction, first of all, the identity of the Ramu and Gopal should be verified, and also the key of the Ramu and Gopal, because this transaction has to be encrypted so that no other person other than the Ishwar, Paras, and Radha should view this particular transaction. So for that, we are supposed to do the key verification and also the identity verification of Ramu and Gopal. Next one is these witnesses has to perform the transaction validation. Transaction validation means Ramu has to sign this transaction and has to send to the witnesses, so that Ramu in future, he should not deny that I have not initiated this transaction. This is called the non-repudiation property, and this can be achieved with the help of digital signature. So that is the reason transaction validation will be done with the help of verification of the signature. The signature is nothing but this transaction will be encrypted, and along with this transaction, the digital signature of Ramu has to be attached, so that the witnesses will verify whether the transaction has been initiated by the Ramu or not. And also, whenever the witnesses has come to a consensus that this particular transaction is correct, then at the time Ramu should not be in a position to give a claim that I have not initiated this transaction. Okay, so for that purpose, this digital signature will be helpful. Next, reaching to a consensus. Just now I told you each witness was is about to going for verification of this transaction and reaching to an agreement that this is a valid transaction. This is called as consensus. So for this, we are going to use some consensus protocols. So these consensus protocols are already available. Many consensus protocols are available in the distributed system, because it is a distributed way of sending the transaction. So whenever the transaction is generated, this particular transaction was sent to various nodes. Nodes is nothing but various witnesses, obviously in a distributed fashion. Next one is creating the immutable ledger. That means whenever the witnesses agreed that this is a valid transaction, now this transaction has to be enclosed in a data structure called block. Okay, like this, over a period of time, several transactions may be generated. This is a one case Ramu to Gopal. There may be a case that Paras to Ishwar, Paras may send 100 rupees to Ishwar, and the same transaction may be generated and may be circulated to Ramu, Gopal, and Radha. Now Ramu, Gopal, and Radha has to verify whether the Paras has exactly sent the 100 rupees or not. If that is a committed transaction, and the transaction will be included in the block. Like that, over a period of time, maybe for around, they may fix, depending upon the blockchain framework, they may fix, okay, we'll wait for this much time, and whatever the transactions committed in this time has to be enclosed in the block created. Okay, like that, Bitcoin is there. In this Bitcoin, for every 10 minutes, one block will be created. Okay, a block will be created for every 10 minutes. In the 10 minutes, whatever the transactions generated or transactions happened will be included in the block, and the particular block will be added to the blockchain. Like this, when the monetary or when the money is involved, the block creation will be happen. So we are supposed to learn how this particular transaction verification will be done, in which identity management, identity verification, or identity management, or identity validation will be done. Next one is how the key verifications will be done, should be learned. Next one is transaction validation must be learned, and what are the supporting public key data structures, public key cryptography algorithms that will help us in achieving this first one and second one, that is transaction verification and transaction validation. And what are the different distributed consensus protocols, in which what are the best consensus protocols, or what are the consensus protocols designed especially for the blockchain, that we are supposed to learn. Next, with the help of this cryptography concepts, how can we create an immutable ledger, which is called a block, and how frequently these blocks will be created, and how these blocks will be added to the blockchain. These are the four main things theoretically we should learn. Then when we go for the Bitcoin case study and Ethereum case studies, we are going to realize these concepts there in a programmatical way or maybe in an application way. This is what the overall view of the blockchain and importance of the blockchain. The importance of the blockchain is, whenever a transaction is created, the transaction should not go waste and should not be corrupted. For that, we are going to place some witnesses, okay, and the witnesses will do the transaction verification, transaction validation, and they will reach to a consensus. Once they reach to a consensus and declare that the transaction is a valid transaction, and over a period of time, they will fix that, okay, this much period of time, and in this period of time, whatever the transactions committed has to be included into the block, and the block will be added to the blockchain. So these are the 4 steps must be learned by us, so that we can understand the further things. So these are the main operations that will happen in the every blockchain framework. So with this example, block is a trusted distributed ledger which is shared across the business process. It allows a shared replicated permission ledger with consensus, provenance, immutability, and finality. So it is a shared replicated. Replicated means same copy will be shared among all the participants. Permissioned ledger. So anyone can view what are the transactions happened if they are having the valid key. We have seen here, if they have the valid key, if the key is verified, they can view it. So here, blockchain is a trusted distributed ledger which is shared across the business processes. It allows the shared replicated. Shared replicated is nothing but the same transaction was replicated to all the participants in the network. And permission ledger with consensus. The witnesses has to reach to a consensus that whether the transaction is correct or not. Provenance. Provenance is nothing but who initiated the transaction, or who is the author of the transaction. For example, if you look at your if you purchase any land, okay, whenever the land registration is happening, there will be a document will be attached called link document. That means from whom you are purchasing the land, and from where the seller is purchasing the land. This entire link will be maintained. Like that, this provenance is nothing but who is the author of the transaction, who verified the transaction, and who committed the transaction. These details will be available in that particular along with the transaction. That is what we call provenance. Immutability, you cannot change the order of the transaction. Immutability and finality. Once it is committed, you cannot roll back. So these are the features. Okay, these are the features supported via this distributed ledger, and it is also called as blockchain. And here is the example. The same ledger is shared among all the participants. So what is the advantage whenever you use this blockchain for the business? Obviously, the shared ledger, which will be shared among all the participants. So whenever the same ledger is sent or is shared among all the participants, there is no scope of making manipulations in the ledger. In the same way, smart contract is nothing but you are going to add some intelligence during the contract. So here you are going to add some business terms embedded in the transaction database and executed with the transaction. So whenever that particular condition was satisfied, automatically the transaction will be initiated and will be sent. It is just like whenever you go late to a particular meeting, if you are late by 10 minutes, you are supposed to pay 50 rupees fine. For example, if it is a condition, then if you go late by 10 minutes, automatically the amount has to be, the 50 rupees amount has to be deducted from your account, and it has to be credited to the meetings, that is the one who is organizing the meeting. So it automatically the amount has to be transferred. You don't need to do any initiation here. You don't need to do any transaction verification, transaction initiation here. Automatically the transaction will be generated, performed, and the amount will be sent to the other party. This is what we call smart contract is. We'll see details about the smart contracts in next lectures. And next one is privacy. Whenever the privacy is nothing but here you don't know, you are going to hide the identity of the person. No one know the identity unless until they verify the key. So that is what the thing we have seen in the last thing, that here transaction verification, identity and key verification. If the proper key is having by the participant, then only they can be in a position to verify the identity. Otherwise, they cannot verify the identity. So when the identity cannot be verified, obviously privacy can be achieved. So ensuring appropriate visibility, transactions are secure, authenticated, and verifiable. And obviously, if you reach these three things, security is there, privacy is there, and verification validations are there, then automatically trust will be built. So transactions are endorsed by the relevant participants and also the witnesses who we elected as the trusted one. So automatically the trust may build. So these are the four main features of the business blockchain for using of the blockchain in the business, and also use of this blockchain will save the time. Obviously, auditor no need to go to every participant and no need to verify the ledgers, and also removes the cost. Overheads of the cost of the intermediaries can be removed. This is called as a direct benefit transfer. So the one who are directly benefited will be getting the things, so that the intermediaries can be avoided. Reduces the risk. Tampering can be reduced because it is DLT, distributed ledger technology, is immutable and final. So tampering is not possible in this case, and fraud and cybercrime can also be avoided. Next one is increasing of the trust through shared processes and record keeping. The trust can be increased because whatever the records were kept, everyone will be having a shared copy. Because here look at the distributed ledger technology allows the shared replicated, okay, shared replicated permission ledger. That means the same copy will be available with everyone. So there is no chance of making the chance of making the discrepancy in that particular or manipulations in the transactions. So how the blocks look like? So a blockchain is a historical record of transactions, much like a database. So this is the block in which the list of transactions were recorded here. So blocks in a chain is equal to the pages in a book. Each page in a book contains the text, the story. Each page has information about the help, title of the book, chapter title, page number, etc. These are the metadata about the transaction. So a block consisting of set of transactions and metadata related to the transaction. So in a blockchain, each block has a header which contains the data about the block. So every block consisting of a header and data section. The header consisting of the metadata about the transactions in the data section. Okay. So technical information about the transaction, a reference to the previous block. Okay, reference to the previous block, a digital fingerprint, also known as hash of the data contained in the block. Among other things, this hash is important for ordering the block verification, validation. As just now I told you, the blockchain is a single way. Whenever you add any block, it has to be added only at the end of the block. You cannot insert in the middle, or you cannot insert at the beginning. So why? What is the reason? Because, for example, this is a hash of block 0. That means whatever the transactions information, everything is there. All this transaction information will be sent on to the cryptographic hash function, and a hash value will be generated. And this hash value will be used by the next block in its block. Now the entire block will be hashed, and this particular hash of the block will be used by the next block. That means if you make any changes in this block, obviously the hash value will change, and the subsequent blocks will become invalid. That is the reason you should not insert the block at the middle. You should only insert the block at the end of the blockchain. So the contents of the block, example information about the transactions will be available here. Whenever you look at any blockchain, the first block which is created is said to be the genesis block, which is called, in case of your linked list, you will call it as a head node or head node, like that. So like that, in a blockchain, what are the first block created? That block is said to be the genesis block, and you can have any number of blocks here. Now, like for example, you have added over a period of time around 10 transactions were generated, and these 10 transactions were validated and included in the block. Now in the next 10 minutes, some 20 transactions were generated, but you can fix the size of the block, how many transactions must be included in each block. Even though the transactions generated in the specified period are greater than the required amount of the transactions in the block to be fitted, only the committed number of transactions that are to be included in the block should be included. For example, even though in a period of time around 20 generated, we have committed that only every block should consist of only 10 transactions, then only the first 10 transactions created will be included in the block. Like that, after 10 minutes, next 10 transactions will be taken and included. Like that, the transactions will be included in the block, and this entire block will be sent on to the cryptographic hash function, and hash of the block will be generated, and this hash of the block will be used in the next blocks. Like that, the block generations will happen. Assume that over a period of time 100 blocks were created. Now if any new participant joined in the network, for example, here participant A is there, participant B is there, bank is there, financial institution is there, regulator is there, okay, and auditor is there. Now some government added in this, some new participant joined in this. Now what will happen? Whenever the new participant install the database application, blockchain application, then, and whenever it is connected to the blockchain network of the corresponding business, this entire blocks that are created, we have assumed that around 100 blocks were created. All these blocks will be copied onto the new participants system. That means new participant will also get the same copy of the list of blocks that were generated. Are you getting now? That is the way this distributed ledger technology will use the shared replicated data or replicated information that was there in the block. If any other new participants, for example, participant Z was added, whenever he installed the blockchain application and he connected to the blockchain network of this business, within seconds, this entire data will be again replicated into that person. So like that, whoever joined the network and who has permission to access this network, all those participants will be in a position to get a shared replicated ledger, so that they can also start the transactions. They can also participate in the business. This is the way this blockchain will help, and the structure of the blockchain looks. Now, as the blockchain has been popularly used in many businesses, here there are 4 different versions of blockchains are there. This must be known to you. Blockchain version 1.0, distributed ledger technology. Only DLT technology is this. Only distributed ledger technology, and that is especially designed for the cryptocurrency. So blockchain version 1, that is the blockchain version or blockchain pattern that was used by the Bitcoin, is said to be the first generation blockchain. Okay, which is called a blockchain version 1.0. Now blockchain 2.0 consisting of blockchain 1.0 plus smart contracts. So that means distributed ledger technology is there, supporting to the cryptocurrency is also there. Along with this, the execution of the smart contract, the facility is also there. If you add smart contracts, then it become blockchain 2.0. Smart contracts are small programs that live in the blockchain. So this was an example of this type of blockchain version 2.0 is Ethereum blockchain. While coming to the blockchain 3.0, blockchain 2.0, that is what are the features available in blockchain 2.0. That means the distributed ledger technology, smart contracts, and decentralized applications. If you add decentralized applications to the blockchain 2.0, then it will become blockchain 3.0. So dApps is nothing but front-end applications plus smart contracts. Whenever you add this, example is decentralized application development with Ethereum. This particular development is said to be blockchain 3.0. While coming to the blockchain 4.0, the blockchain 4.0 will be consisting of the features of blockchain 3.0, that is front-end application, smart contract, distributed ledger technology, plus industrial applications. So using the blockchain for industry applications such as automation, enterprise resource planning, and many other things. So example, blockchain for supply chain management is the best example that you can refer under the blockchain 4.0. So these are the developments over last 10, 12 years about the blockchain. So the first blockchain, Bitcoin based blockchain, is blockchain version 1.0. Next, if you by introduction of the smart contracts with the DLT, which was there in the Ethereum, is the blockchain 2.0. And if you add decentralized applications, it will become blockchain 3.0. And if you use blockchain 3.0 for the industrial applications, then it will become blockchain 4.0. We'll see this taxonomy of blockchain system. Here, 3 categories are there in the blockchain systems. Public blockchain, which is said to be permissionless. In order to join to a public blockchain network, no one's permission is required. Directly you can join the network. This is the open to the world, attracts many users, and communities are active. Example, Bitcoin. Bitcoin is a public blockchain. Anyone can join the Bitcoin network and can start the transactions or trading on the Bitcoin, which are called public blockchain. There you don't know who are the witnesses. Anyone can verify your transaction. Okay, that is what the popularity. And who initiated the transaction and who is verifying the transaction, everything will be kept secret. The identity is completely secret. That is what the beauty of the public blockchain or permissionless blockchain. Permissionless, the name itself indicating you that no permissions are required from any authority to join into this kind of networks. Next one is private blockchain. Private blockchain is completely opposite to the public blockchain, which is permission blockchain. It is for small communities. Okay. Many companies are developing frameworks for its efficiency and auditability. In the public blockchain, you can have the efficiency and auditability because many people will be involved. Anyone can raise any problem in that. But in case of private blockchain, it was confined to small communities and also having holded by one authority. If anyone wants to join into the private blockchain, has to seek the permission from the authority and get the public and private keys, and then only they can join. So in such a cases, the efficiency and auditability is a question, but many companies are developing the frameworks for efficiency. Example is IBM Hyperledger. IBM Hyperledger is a private blockchain. You can, if you want to generate private blockchain based applications, you can work with the IBM Hyperledger. This is in the fourth module. We are going to see the other blockchain frameworks in which we are going to see the IBM Hyperledger. Next, consortium blockchain. It is also called as hybrid blockchain or federation blockchain. Consortium blockchain is having the features of both public and private blockchains. It can be applicable to the business applications. Example, Ethereum, which consisting of cryptocurrency and also general business applications. This consortium blockchain example is like this. For example, here private blockchain is there. Let you consider our university. Our university may run on a private blockchain where the faculty want to report to HOD and HOD has to report to the dean, and dean may report to the vice chancellor. Like that, a system was mentioned, and whatever the academic activities are there, everything are recorded on the blockchain. Now, this is completely private. Only HOD will approve whatever the transactions generated by the faculty. Okay. Only dean will approve what are the HODs initiated, what are the transactions initiated by the HOD. Only vice chancellor will approve the dean. So this is a fixed structure. So it is a private blockchain, and no one knows what is happening outside. No one knows from the outside what is happening here. Now, AICTE or MHRD or any other UGC wants to verify the academic activities going on the campus. Now, the university may generate some public and private keys and may give to the UGC, so that UGC may join and may verify, may perform the auditing of the university blockchain. Now, what will happen here? In the first case, the entire university is operating in its entirety. In such a cases, private blockchain. Now, the public is involved, that is UGC or other person was given permission, okay, and they are coming and joining our network, and they are going for auditing. So now, what it is becoming? It is a mixed mode, both private and public mode. That is the reason that mode is said to be the consortium mode. It can be applicable to business applications, also called as hybrid or federation blockchain. Now, if you use this blockchain only for the cryptocurrency support or only for currency support, then Bitcoin blockchain you are supposed to refer. If you want cryptocurrency support and smart contracts, then Ethereum. Only smart contracts you want to go for. You don't want to focus on the cryptocurrency, then use IBM Hyperledger. I hope by this time you clear. If you require cryptocurrency and smart contracts, you learn Ethereum. If you want to learn only cryptocurrency development, then understand the Bitcoin. I don't want cryptocurrency. I'm only focusing on the business application, especially smart contracts. Then IBM Hyperledger. So what is the meaning of this? IBM Hyperledger don't have the facility of cryptocurrency. Okay, Bitcoin don't have the facility of smart contract. But one blockchain framework is there that has the support of both the cryptocurrency and smart contract, and also the decentralized application development. That is what we call Ethereum. So we are going to cover both the Bitcoin, Ethereum, decentralized applications and also the IBM Hyperledger in this course.